Hi everyone, how are you? As I talked to you before, I won't be in the school today and tomorrow. Okay, I'm fine, everything will be fine. And I need your help here because you will self-direct yourself with the teacher over there showing to you the video and be sure to follow the instructions as you see here in the video, okay? This lesson, it's supposed to be simple, it's not heavy. And the lesson today will be this thing here I'm showing to you. It's about radian. And the next lesson, Friday, for block B and block D will be Monday, will be math, okay? Just for you follow up this direction here. But let's go together here, understand how this lesson works. Well, the lesson starts on page 763, okay? Also, the material you need is a protector. I left the box, the crate over there next to my table. You can pick on protector over there. Use the protector to draw each angle as you see here. Positive 50, 125, 135, and negative 135. Okay, great. I hope you did these things here. And the key terms for my lesson today is theta, unit circle, and radians. That's my goal today in this class. Great. Let's go together, understand those commitments over here. We have a problem here in King Arthur's Knight. They are talking about this kind of relationship, about the positioning and other stuff. How can we write this thing here? Use the idea for which we know already as circumference. Okay, we have 12 positions like a clock. Great. If you had class with, I think, Miss Bishop, she has a calculator with exactly this thing here. Oh, calculator, I'm sorry, a clock with exactly this thing here. But let's go here, for example, here. The first angle we could select, that's 12, 360 divided by 12. Which angle will be how much? To be 30 degrees, yes? The first one, 30 degrees here. In the sense of circumference, 2 times p times radius. Oh, the radius is stable. We don't change this thing here. However, 30 degrees is how much percentage of the full circle? Oh, mister, it's 30 divided by 360. Yes. 30 divided by 360. And it will be pi times radius. Simplify the fraction and keep doing. The next one will be 60, 90, 120, and so on, so on, so on, until you complete everything. Be sure to simplify the fraction. Nice. I hope you did. You finished this thing here. I'll not go over everything here, but you have time in classroom. Just pause the video and complete the questions 1 to 4. Nice. I hope you finish. Compare your results with your friend next to you. Attention to do that and be sure if you got the same thing, same idea. You can read here. It's pretty simple. Let's go with the activity number 1. We talking about the difference between radians and angles. Okay, again, as I said to you, our content right now is related more with geometry and algebra 2 together. Great. How can we write the arc length in radians? Here's the formula: 2 times pi times radius, and we make this thing here. Be sure to measure that angle, divide by 360. Exactly the thing I did before. Great. If you keep doing this pattern here, you will notice some important results. For example, 30 degree, if you did there before, oops, my bad here. Let me just turn on. Nice, it's back. Follow this formula here, 2 2 times 30 degrees times pi times radius divided by 360. If I simplify those guys here, will be pi times radius divided by 6. That's the radian. And remember here the symbol for angle theta. That's something we're talking about a lot. We have for 45 degrees. I want you to explore with your friend next to you and explores all other situations is going over here. Great, it's talking on this page. Same idea here in number 3, but be sure to use the protractor to measure the angles here we're looking for. Be sure to explore each one. What does it mean? And the activity 1, compare the results from Jaylin and Malik, and why Jaylin is correct, why Malik is not correct. Try to explain your reasoning, okay? And compare your results with your friend. I'll not just give the answer here. I want you to work and share with your friend next to you. Think with radians when pi is a constant. That's something interesting. Pi is a constant, never change. It's 3.514 always. And we're just comparing the results here. How much is 3 radians? How we do that? Pretty simple. 3 radians, it is exactly as, attention here, 3 radians. Then we write here 3 equals what? We need to check what we're comparing here. How much is 1 radian? You know? You don't know? You're confused? 1 radian is pi. And 3 radians. What is this? Attention here on another example I give to you here. 6 radians here. How do we know that thing here? 6 radians is a little less than 360 degrees. How do I know that? Because 2 pi times radians, 2 pi equals 6.28. This is exactly 2 pi radius, 360 degrees. Okay? And here, pi is exactly 3.14. Pi I know is 180 degrees. Then I know this 3 here is more close to 180 degrees. Okay? 2 radians. Well, 2 radians, I just keep doing the same thing. I know pi is 180 degrees. Pi equals 180 degrees. I like to do this thing here to help me to figure out. And 2 radians equals what? Let's do here, cross multiply will be pi equals 360 and 3x equals, I call this x, okay? X equals 360 divided by 3.14. And just do the calculator, you figure out, oops, the angle here. Okay, that's the method. And keep doing for the other ones here. And if you keep working the same activity, explain to you better how to convert radians to degrees, degrees to radians. That's a thing important to keep working and understand the pattern. Okay, I have one word problem here about the Corinne. She's talking about this. And the last thing here is the unit circle. I think one of the most important things ever for this lesson here. I want you to try to convert and write this unit circle as degrees and radian. Okay? If you're stuck on that, no worries, we can refresh this in classroom later. And that's it. We finished this. And the homework is page 773 and 774. Great. Guys, have a great day. Enjoy your weekend and see you back next week. Bye bye.